How are you doing?
I'm doing pretty well. The last question is actually pretty easy.
Oh yeah, never said no like
Yeah,
that. And
yeah. It was just my only problem was how is um well the value I was returning in my size method function. That was the only major problem. Once I figured that out, it was easy.
that's good.
Hi, everyone.
Yeah, I figured out the problem. It was my size function.
Which one?
The size function.
Ah, okay.
Yeah, I wasn't accounting for the head deletion.
Yes.
So
Okay. Yeah, I had
yeah.
figured. Namrata, thanks for that Reddit post. That was awesome.
Oh, thank you. Yeah, it was kind of hard to kind of like conceptualize what was happening, especially like as the vector was like empty and like the node had like usually like the node has the data and like the next, and this one was like a little different. So just it was easier for me to draw it out.
Right. Yeah, just to clarify, so for your Reddit, when you had the hip example, so if you continued further, hip would also have the null character after that, right? You would still have to, after the P, it would still point to a null, and then that null will point to a empty, right? Same thing that you did with high.
Oh yeah, that should be there.
Okay, all right.
Okay, yeah, that's a good point. I'll go edit that.
Yeah, no, it's okay. I figured it should be the same, and because we have to do that outside of the for loop or something, or whatever iterative process.
Yeah.
Yeah, I got stuck at traverse. I have no idea what I mean, all it says is it got lost, and I'm like, oh, great, thanks. So but what threw me off is that the traverse method is a const, and I tried to assign like a current node. Like I start out with a current node, kind of like the insert where you have a current node and then you assign it to this. So you want to start at the beginning. And that didn't allow me to do that because of this is not a const. So I was like, wait, how do you do that? I don't know. So I did something weird so that I avoid the error. So the const is just, I don't know. I never understood const. But
you should be able to assign to a const node this.
really? Because I did this, so kind of like the current method, you have tree node pointer current equals this. I had that, and it didn't allow me because of the fact that this is not a const tree node.
Well,
So
is the left-hand side of the equal sign, does that say const node
no,
star? Yeah, it needs to say const
it
node
has to say,
star.
oh, you just put const there and then that's it. No. Okay. Yeah, this part throws me off.
The
Okay.
warning was just telling you that you were trying to assign it to a non-const pointer.
Okay. All right. Oh my goodness. Jeez.
So this is the traverse function.
Yeah. Okay, yeah, you're right. I did it. Okay, so it doesn't. Okay.
Yeah, it should be like pretty similar to your
Insert method.
yeah.
Okay. All right. Yeah, because the error message don't say much. So it's like, okay, what? So
Namrata, I was hoping you could maybe somehow walk me through what's supposed to happen in the get completions at node. I'm basically just like trying to figure out the first couple of steps as far as how you're supposed to like append to, I assume you're supposed to like append to this string. So like the deeper and deeper you go, that the partial that's attached to each thing that gets pushed on will get like longer and longer.
Mm-hmm.
So at the beginning, the way I have it right now, I have everything that he has in the helper code. I clear the completions vector because he said to. And then the first thing I do before the while loop is push into the unprocessed nodes vector a continuation that's made up of this node, like the current node, and the partial.
You do that in the while?
No, outside of the while.
Okay, yeah, okay.
Because the while loop is like based on whether or not that's empty, so that wouldn't work. And the partial that I attached to that was just an empty string. Is that because I wouldn't have any data relevant to this node because it's sort of based on the parent? Is that right?
Yeah, that's what I did.
Okay. And then so like as you're going into it, you just sort of like take off what's ever on the front and then push all of the children, or are you like checking each of the children to figure out like what you're supposed to do with them, or what was sort of like the steps you took in the while loop?
In the while, I did the first thing where you check like if the null character. So I just check if that like that continue node or that continuation, like the CONT, if that one has like the null at the end, then you add that like partial to the completions vector.
Oh, okay.
And then after that, I like loop again with the for through the nodes of that CONT continuation. And then I check if like the next of those are not the null pointer, and it's sort of like the breadth first where you add like all the children as like the continuation and like the partial plus that extra whatever that like current character is.
Okay, so like every time you find the null terminating character, that's when you push that onto the completions vector.
Yes.
Okay. And if you're like going down, there wouldn't really be a situation, I'm guessing, where, no, that doesn't make sense. Never mind. So the other thing I was like kind of like maybe overthinking about, that I was like kind of worried about, was when I was doing that, pushing like the current node, and then I guess what I'll be doing to push the child nodes and all of that stuff, those are like local, or the way I did it, I didn't say new continuation or anything like that, but I'm pushing them into a reference vector, which exists outside of this function. So then I was like worried that once this function ends, that those things that I pushed in might be dead afterwards. Did you use new or anything for the continuations that you pushed in?
For continuations, I didn't, because like I think in the starter code he also gives like the queue. It's not like a reference or anything. Where the reference vector you're talking about, is that the completions that you were like referring to?
Yeah.
For that one, yeah, I don't think you need to use anything, because it's just like it's actually just the strings, so you can just like directly just push that like partial.
Oh, right. They're string vectors. Right. Okay, cool. Awesome. It's a very sort of like tricky, I felt like the quests before that were all like pretty simple. And then this one is like kind of confusing. Like I was having trouble even sort of visualizing what I would be doing. So it's kind of hard.
Yeah, this was definitely one of like the hardest ones in this class.
I just started setting
Go ahead.
up.
Go ahead.
I just started setting up the quest, And I'm just wondering what I need to look out for, you know? If there's anything to look out for in this quest.
I will say for get completions, make sure you include a queue, include a header file. Cause I was stuck on that for ages and I didn't know I need to include that. So just make sure you include the queue thing in the beginning. That will save you a lot of time and headache once you get to get completions.
Okay.
Yeah, I haven't finished it yet, but other than this get completions that I'm on now, I feel like it was pretty straightforward while you're working through the quests. The specifications do a pretty good job of explaining what you're going to be doing, and it's just when you get to get completions that's sort of a different headspace than the rest of it, in my opinion.
Anything on destructors? Any issues that you ever come across on destructors? For the node? Any issues there?
No,
No?
this was like super, to me anyways, was very reminiscent of some of the other quests we've done in the past with nodes and how you handle the destructors with them. Especially because I feel like we did the same thing before, where you have like an outer class and then an inner class that's the node. So the outer class's destructor is like just delete the head, and then the inner class's destructor is sort of like this recursive deletion of children nodes.
Because
Those aren't tricky.
because again, I'm picturing like a bunch of vectors attached to each other, like so many vectors, and so you're literally recursively going through each vector and clearing it, or whatever vector it points to, you gotta clear that, and then so it sounds like a bunch of clears that are happening. I don't know.
I
Maybe I'm
didn't do
making it more
any
complicated.
clearing.
Oh, you didn't do any vector clear or next.clear or anything like that, or? Oh,
No, my thought process was that, well, vectors, just by themselves handle their own memory. So when they go out of scope, they
they're already
handle it
it's
for
already
you.
it's not on the heap.
Yeah. Well, it may be on the heap, but whatever the case is, it handles it for you. All I worried about deleting was the nodes themselves.
I think it's
Hmm.
because the vector, like, is like the vector itself stores the node. So
Yeah.
like as long as like you're deleting the node and it's like the recursive thing, like you're deleting whatever like valid like pointers are in that vector. So you don't really have to like, you're not deleting the vector, you're just deleting like the nodes in them. And it sort of works itself out because of it's like the recursion.
Did we do this in the previous quest? Now I'm kind of like blanking out on this one. Maybe I'm making it more complicated than
I don't think we had like a vector of nodes. We just had like a linked list.
Yeah.
Which is like sort of similar. But yeah, it's not very complex. You're just sort of stepping, it's an iterative thing, like step through the whole vector and delete each node. Because if you call delete on null pointer, like, if there's empty spots in your vector, it doesn't do anything wrong. So.
Okay.
Like for example, like the next vector, like you're just deleting because they're all pointers, you're just deleting, like you're just going through that vector and deleting each like child in that. And it's like the recursive one. So it'll like go through like that next and that next.
And that next and that
Yeah.
next. Okay. Okay.
Yeah, and since it's recursive, it should, before it deletes the root node, it'll go all the way down or sideways or however
I
you're
see.
visualizing it
Okay.
through
Yeah.
all of the next vectors until
you
it
hit
gets to the very end. Yeah.
Yeah. Until you hit. Actually, it says until you hit an empty vector or null
Yeah.
pointer, right?
I think it would be empty vector.
Empty
is what
vector.
would be the
Actually, that would be more
stopping point.
appropriate, right?
Yeah.
Oh, right. Okay. 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 Got it.
Yeah, don't overthink that because you'll
Yeah.
be doing a lot of overthinking when you get completions.
Completions. Oh man,
Yeah.
haven't gone there yet. Shoot.
Yeah, there was this one mini quest in the last quest where he says a bunch of stuff, but I guess the point he was trying to make was don't overthink it because like the solution was just really easy. Like it was one of the I forget which one, but it's the one that said woo biggie.
I think it was a resize one. I think that was it.
Yeah, that's the research
Hmm.
one, yeah. You just had to like do one thing. I don't know. So yeah, if you're overthinking things, like if you're adding too much stuff to your programming, you're probably doing something wrong, or you're just really like, yeah, or you're looking at the wrong place. Like sometimes I end up looking in the wrong places, but that helps me understand that, well, if this doesn't change anything, and if this doesn't seem to like, if this seems correct, then I could just look somewhere else, you know, in the code. That's why I had to figure out in the last quest. You know, the announcements are kind of funny. Frozen ant. That's kind of funny. I don't know. It's like weird names, these quests. I'm sorry, I'm just a bit stressed. Yeah.
No, yeah, it's okay. I remember when I got the password to like this current quest, I couldn't figure out like which part of like that
I
sentence is the
know.
actual password. So it took me a
Yeah.
while just to get that.
I normally have to like copy the whole thing and then just like paste and delete,
Try
paste,
different like
delete. Oh, it's just that
combinations.
part.
Yeah.
Yeah.
That it was a pretty weird name. Like, yeah. I wouldn't think that slash would be like part of the password, but yeah, the dash. Yeah.
I'm sorry, I was just reading up get completions. What is this quest about? You're getting a word and finding words within something. I was just trying to read up on it.
This was like really confusing to me. I don't know if you saw the post I made in the subreddit, but
Ah.
basically what it is like imagine that the user types, they have their tree, and using this function they can put in a word like hi,
Yeah.
and this will both of these functions, the tree one and the node one, will return all of the things, all of the words you could make off of that word that they passed in. It's basically autocomplete.
Okay.
I don't think we put in the actual string, do we? The only it's sort of just like a breadth first traversal with like a limit. Like we don't actually put in there's no argument for like the prefix or anything, right? For the get completion specifically.
For the tree one,
Oh,
there
yeah.
is that they pass in a string.
Yeah, but not for the node one. It wouldn't. Yeah, node one is just
Right,
like
yeah,
the
yeah.
traversal. Yeah.
The node one is like the inner working of the tree one. So like if they passed in hi, then ultimately between the tree and the node, get completions, it would say hi, him, his, he'll, whatever, words that you have already stored in your thing.
Okay.
So you're sort of like building up this collection of, like,
Many
if you went down from the root, if you went HI, what other things can you get to from there?
I take, okay.
Is what you're
Okay.
doing with these. And I
And you're
assume I haven't done it.
counting that number of, okay, you're counting the number of completions based on a prefix of something, or
Yeah, in the node one, you don't worry about the prefix. I think in node, it's just based on like the current node.
okay.
But ultimately, once you get to the tree one, that's sort of how it's being used.
I see. Okay.
And Namrata, I assume the only like actual completions are the ones with null terminating characters at the end, right?
Yeah, that's the only. Yeah,
Okay.
you just push when you find that, and then yeah, that's the only thing you actually push into the completion vector.
Okay.
So does the limit indicate how far? Oh, okay. So you don't want a word beyond the limit.
I don't know if it's
Right.
the word. It's like the number of completions. We don't want.
Oh, limit is the number of completions of,
Yeah.
like,
So
let's
it's
say
sort
you,
of.
okay,
Oh,
sorry,
sorry. Go ahead. Go ahead.
sorry. Like you said, hi, you could say him, his, hit. So the completions are the number of times you hit. Let's say if it's just the limit is 3, you'll only oh wait, how's,
So like
sorry.
those words would be the elements of the completion vector, and the limit is the size of that vector. So like.
Oh, the size of the vector. You mean
So-
the size?
So for example, let's say the limit was 5, and like you start out with hi, then it would like try to go up until 5 words that had that prefix hi, like him, his, hill.
Oh,
But then like
it's-
if you had like, let's say like an extra, you have like 5 and then like something else, it's still like a valid completion, but you've reached 5. Like it's just sort of like an if statement at the end. Like if the size of your completions is more than your limit, then you just want to stop. You don't want to add more than that.
so that's what you're returning. See, I thought you're returning. I thought you were returning. I thought the limit was if it's the size of the number of letters in a word, and then you return the number of times you encounter him, his, hit.
That's a totally different
Oh
thing.
my God. Okay.
That would make it much more complicated.
Wow.
Yeah,
Okay.
that sounds crazy.
All right. So it's just the
So-
number of, okay. Sorry, go ahead.
If you hit the limit, does that mean you just stop adding into completions? Like, do you still?
Yeah, that I just had like if at the end, like if it hits,
Okay.
if the size is more than limit, just break out and then just return.
Okay. So you, even if there are more, like the number you're returning at the end isn't like the total possible
No, it's just the size of whatever
up
completions you
to
currently
the
have.
limit. Okay.
Oh, so you're
Gotcha.
returning up to the limit.
Yeah,
Limit
so
or less. Okay.
it could be limit, or like if there's less, it would just
Yeah.
be that size.
I see.
And I guess you could just add a condition to the while loop, couldn't you? That says like, while unprocessed nodes is empty and completions dot size is less than limit or something like that.
Yeah, that should work too.
But the order in the while loop is like, you get the front, you pop the front off, then you add all of its children into the unprocessed nodes or queue, and then you do something with that one you popped off.
The way I did it was the first thing that it gives you is like you have that popped. Yeah, you have like the cont node, the
Mhm.
cont continuation. The first thing I did is I just checked if that, like, if that partial had the null in it, and then I added it as completion, and then I just processed. I like went through its next to add the rest of its children. I don't know if it should matter which way you do it, because you're not really changing the cont continuation either way, but I think it,
Mhm.
yeah, I'm not sure if I'm not, that's a good question. I don't know if it should matter, but I did it that way and it worked, but I think it should work either way.
Well, if the partial has the null character at the end, wouldn't that mean that that particular node wouldn't have any children anyways?
I don't think it would, because it could be like, I think in the case of like the his, like the high, it could be one, like no, like that's a word, but then like the his could be like the other word. So that I, if the I was the character, then the null would be like one possible scenario, and that would be a continuation, completion. But then there'd be like other possible letters I could continue on for other words. So you still process
Okay.
all the next
I
of
see,
that
okay.
I.
And when you're like pushing things into the queue, the children, did you just say like for the string part, the partial, did you just say um like whatever the current node's partial is plus something?
The current node? For
Like
pushing into
the
completions?
the yeah, like I'm just thinking about when you're pushing the children in, so you popped off the front and it has some partial associated with it. Um, and then as you're pushing the child nodes into the queue as continuations, that partial would be the partial of its parent plus something else, or is it just the partial of its parent?
It would be the partial of its parent plus like that index, like, because that index is like the current letter.
Plus that index. Right. Yeah. Okay.
Yeah. It was a little weird because
Yeah,
like
I
the
keep
indexes were the
forgetting the
letter,
index.
but
Right. Yeah. That makes it like doubly confusing. I feel like if these nodes just like had the letter as a data element, this would be like a lot more straightforward, but I guess this saves space or something. I'm not actually sure.
yeah, I think it was, yeah, it was like in the beginning we were talking about how this was like another variation of like the hash table type structure.
Yeah,
something.
I was trying to like Google this specific kind of tree, and everything I found wasn't quite like this as far as how the nodes were handled, with them having no like data elements. So I was kind of having some trouble. You said it's a variation of a hash table.
No, I think this is like another, like, it's like the same thing that a hash table does, kind of.
Oh,
I think
okay.
in the specs, but it's like another data structure. But yeah, I think when I was searching it up too, a lot of the examples online, like the way the class is structured, like the nodes, it's different. It has like a children vector and then like itself, but this one is just like the next vector. So
Right,
it
yeah.
was a little different.
But it's basically the same, right? Like instead of a data spot, you just say whatever uh, vector spot sent you there.
Yeah.
Okay.
where in the function, the get completions, you're saying like if you're trying to find completions of, let's say, high, so how do you know what word you're completing? I mean, I think I'm probably misunderstanding the mini quest.
I
Because
think
all
that-
your
Oh, sorry. I think that's what. Yeah, I think what Dylan was mentioning. That was like there's 2 get completions. That's for the tree.
oh, I see the one. Oh,
There's a tree and there's a node one. The node one, you're not. It's just going from like sort of like that root or starting point, and or whatever it's called on, which would kind of would be like a root unless you call it on something else. But then the tree completion is where you can put in the actual like prefix string.
but how would you know? Okay, so the 6th mini quest is the node completion. The 7th indicates the string. So, which is what we want to complete have those completions, right? The string. But from a node level, from the node itself, how do I know what string I have to create these completions, I guess, from a node level?
I don't know.
The node probably shouldn't care at all about.
The
The
node
string.
shouldn't care.
Yeah, it's just based on itself. Like, what is every sort of word I can make off of this singular spot? But then when you get into the tree version of it, you'll probably check, does this word that they passed in exist? And then if it does exist, then then you'll use the traverse function to like traverse to that specific spot in your tree.
Mhm.
And then you'll pass that node in to your node get completions.
Okay.
Or not necessarily pass, but you would like call it from
Yeah,
that
you
node.
call it from that. Yeah.
So if I'm supposed to do the 6 mini quest and I don't know what the string is, so you're getting completions of, oh man, okay, whatever.
It's like all possible completions. It's like you're just like it's kind of like if you think of it as like the traversal, you're not trying to find any specific thing. It's like you're at this node and you're just trying to find like the traversal of it, like every other possible word that's made from whatever node I'm starting at.
So from a node standpoint, you're starting from, you're actually going through each, well,
You're starting at this and then
you start at
traversing.
this, yeah, and then anything that has an actual allocated entry in the vector, then you get every completion from there, or oh god, wait. That's
If you think about it from like just the top level, like say the node you're talking about is the root of the tree, then get completions should just be getting every complete word that exists in the tree.
right. Okay. And then you store
But
that
in the context of trees get completion, instead of starting from the root, it would be like go to the node where high is completed, and then from there find every completion.
so the completion vector is basically every combination of starting from the root. So
From
it's-
this, yeah.
from this, it's every combination up to that limit. And so you're basically you're creating another dictionary in some sense. You're right, or you're putting your dictionary in this completions vector, I guess.
Yeah,
Is
in
that right?
a way,
Up to
you're
a
like
certain limit.
actually making the dictionary, because before the dictionary is sort of like not actually there, because the letters are all just like
Yeah,
vector
each.
indexes.
Yeah.
So
it's
now
just
you're
one letter
actually saying,
per.
okay, here are the words that I have in my tree. You're making them into a string.
So you're gathering,
Or seven.
instead of one letter per vector that's all traversed everywhere, it's now you're gathering all those words into this completions vector, I guess.
Yeah.
Up to a
Yeah.
certain limit. Okay. 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 All right.
And I'm guessing it returns completions dot size because when you use this in the tree get completions, you're probably only going to want however many is in the limit. You know, you'll probably loop over it or something to print them out. You only want
Yeah.
a certain amount to print.
Okay. Yeah, our limit is basically defining our vector size, right? I mean, we're clearing it, then we're
Yeah.
defining that limit, that size of what's the name of the vector? Completions vector.
Yeah.
Okay.
It's so confusing. You've got trees and vectors and queue here, and that's everything.
It's just the wording. I'm just like, at each node, consider all possible continuations, fine, and handle each of the following 3 cases. The character that leads into a child is null, fine. The character has no continuation out of that current node. Yeah, I don't know what that means. If it's no continuation, that must have had a null. Is that what?
Yeah, I was confused about. I don't know what that means. I haven't gotten to that yet. But those
every
3 cases don't make sense to me.
non-continuation is a null. You end up at a null character. I don't know. The character is a valid continuation out of the current node. Aren't they all valid? So that the wording is just
I don't know.
crazy.
Does anybody who's done this already, could you like maybe reinterpret what those 3 cases are for
I'll
us? Because
just share it. Let me share that thing. I was like, what?
it doesn't really make sense to me.
Oh, sorry. I didn't mean to show my code. There you go. If you see it. Yeah, this one.
Now I know everything.
The character that leads into that child is null, which is, of course, but the character has no continuation out of the current node. How can that be? If everything has a continuation till you hit null.
Yeah,
The
I think
character's a valid continuation out of the current node. I would think they're all valid.
yeah, I didn't really follow like 3 cases. I kind of like the first one is like when that is like an actual completion. It's like the whole adding into it, and then the other
Yeah.
2 is I sort of just kind of combined. It's like when you're processing the node, you just want to make sure like it's not null, and then you can add it. Like
Like they messed up the vector, like somebody screwed up the vectors somehow. I don't know.
yeah, I don't know what they exactly like. I feel like the no continuation is it would just be null if it wasn't, and
Okay.
you would just like check for that because you wouldn't be able to access it if it was null anyway.
Right.
So
Right.
Okay.
Yeah.
Okay, just check for a null pointer anyway, make sure. And then if you hit a
Yeah.
null pointer, you hit your word, right?
Yeah,
I mean,
wording is really confusing. Like, it doesn't make sense.
okay. If you don't hit this, for instance, but you hit
They-
null or empty vector,
Valid.
I don't know, then that's a complete word. I don't Right?
I don't know if I did it like that. I just did like, because it wouldn't necessarily like the only way it is a complete word is if it does have the null character, right? So it's
Mhm.
just
Oh, this
like
one.
yeah, so like that's the only time you would add like it would be an actual word. It was just
Oh,
like I think the case of where it's no continuation is like if you had like for example hi, and then you had him, but then like hill is a possible continuation. Like a hill could be a word, but without like that whatever the index of L is null. Like technically like that would be like the non like there's no continuation for like that index, right? But the index is null. So then you just
Right.
like you would
Yeah.
just check because when you're going through anyway, you would just check if it wasn't null. So I feel
Right,
like that
right.
covers it, but I don't know if it's something else. But if it is like I don't know if the mini quest is testing it.
Yeah, secret trophies
Ah.
or something.
So you're saying like if you had hill, I mean if what's after the L, is it possible that it would point to nothing? I don't know.
Like
Point
if
to-
you had high, right, and like you have the I of like the high, like it has its next vector, and those are like the pos. So like the first one, because high is a word, that the 0th index of the next would be like would be a node, would be a valid pointer, right? Because
Okay.
that's like the indicating it's like the null.
Let me
And then
me
let's
go
say
to your-
like, yeah, I think I
Let me
kind
go
of
to
went
your-
off of my
Here,
my
let me go here.
diagram.
Yeah, like let's say, let's go to your example. You had hip, so, like what?
Yeah, so like you go to high, so that the 0th index is a valid
Right.
pointer, but then
Because it has, yeah.
but then
okay.
technically like there could be other like possible continuations because there's other words that could be made, but right now they're all null, right?
So
'Cause
like
it's
let's
not
say
actually
hip,
added.
but then this will be also valid too. IHIP, and then it points to an empty vector.
Yeah.
That's a
Or
valid.
it would point, yeah, the thing you said before, it would point to a node that had the 0th index of a pointer to like another
Oh,
node.
here.
But, like, yeah, it would have to have like that again, or
Mhm.
if that makes
So
sense.
you're just like always checking that first spot in the vector to see if it is not null pointer,
it would
basically.
have
And if
yeah, like when you're adding the partials, it would add that into it. Like that would how it would be there, because that would be the
The null.
yeah, and then this would be
You'd have
pointing
0.
to
yeah.
another like empty node, or the node with an empty vector.
And so that would also be valid hip. Okay,
Yeah.
right. If you hit the, you always check that it point to a 0, well, a null entry.
Yeah, I think it's
I
like
feel like, sorry, go ahead.
no, yeah, I was just it was like when you're going through like the third node, right? Like for me, I just like check like going through every single node, but in this example, the third node, like you're just checking if each index is not null, and if it's not null, then that would be a valid continuation. I don't know if you have to
Yeah.
explicitly check for not a valid continuation, because
Well, you are. If you're
Yeah.
checking if it is not
Yeah.
null, then you're checking if it is null too. So yeah, I
Wow.
think that's what it is. It's just like he's sort of complicated way that he wrote that you're just looping through the vector and checking what exists in
Okay.
there. You need to check that if the null terminating character is there, the 0th element.
Yeah.
And then you go through every other element and see if
Right.
they go anywhere or not.
Okay. Okay. All right. And the
Yeah,
wording
I
is,
was
I
reading that.
hate the
I was like,
wording.
what does that mean? The character that leads into that child is null? Like, why would null lead into a child? Like, that doesn't make any sense to me.
That leads into the child is not, yeah, I'm yeah, I'm just gonna
'Cause,
be
like-
checking for this, so yeah, sorry, go ahead.
Yeah. Because like null won't have any children, right?
Right. Right.
Like, there's no word that has, like, that doesn't even make sense. So
Yeah.
that I didn't really get that, but what you said, Namrata, that makes sense. You're sort of just looping through the whole thing and seeing what is and what isn't there.
Okay. This is no, okay, thank you. Okay. I'll definitely have questions later in the week, so I'll probably be on Reddit on this one. So
have you started it at all, or you're just looking over the spec now?
I got through traverse, so
Okay,
after
yeah,
after I
figured
changed
so
that to const, the traverse started working. So I was like, oh, okay, I just need to do lookup, destructor, and then I get to get completion. And then let's see, the lookup seems easy. So
Yeah, I think lookup is, isn't that just you using traverse basically?
yeah. But this time, I think it's checking for the, I think the null. I think.
Mhm.
Okay, yeah. And destructor. Then I'll get to get completions. See how that goes. Oof.
These guys are so cute with their little hands.
Yeah. Wait until they're frozen.
Well, I don't know why he had that animal from Avatar on here. He's
Where?
up
Have
on
you?
page 5.
Yeah.
I guess he does look kind of similar to these guys.
Yeah, that guy.
I'm gonna hop off and work on
Yeah.
this.
All right. Thanks for all your help.
Yeah, thank
very
you for all the tips.
cool.
Yeah. All right. Have a good
See you
one.
guys
Thank you.
on Friday.
Yeah. Thanks.
Bye.
Okay. Bye.
Hey,
Bye.
guys.